Hi. No, it's a joy to be here. Thanks for having me. My name is Edwin Hubble. I am an American astronomer, and as far as my research goes, as far as what I've studied, essentially, I discovered that other galaxies exist, and I discovered that not only do they exist, but that they're moving away from our galaxy, that the universe as a whole is expanding, it's accelerating, and everything's moving faster and faster away from itself. Um, Now, how we got started on this was we noticed that there was a certain patch of the sky, a certain patch of the Milky Way. Um, it was known as the Andromeda Nebula, and up until recently, we've thought that this was just a new solar system forming. Um, but with my group, you know, we naturally we were curious. Why? That's the question a scientist will ask himself. Why does this happen? Why does this happen? And you try and find the answer. Well, um, we focused our telescopes on this part of the sky, uh, and honestly, I'm very lucky in the fact that I was able to accept a very prestigious position at Mount Wilson Observatory. That's where the main experiment took place. And I actually got to work with the Hooker telescope. It's the biggest telescope of my life. It has a 100-inch lens, and as I arrived at the Mount Wilson Observatory, uh, that was about roughly the same time that this that all of this was happening. So with the help of that telescope, I was able to focus for a while, and this was a big time for the world too. There's some significant things happening. Um, just to name a few, the League of Nations was established around this time. Women gained the right to vote here in the United States. The Roaring Twenties and the following stock market crash and the Great Depression took place, obviously, in the 20s and 30s, um, which was sad, but it was a great time for science. Now, it wasn't it wasn't all me. I had a lot of help. There were a lot of discoveries that paved my path uh, in finding these things out. For example, in 1908, a scientist named Henrietta Swan Leavitt discovered these things called Cepheid variables. They're stars that they kind of fluctuate their brightness. Um, like they get really bright and then they get really dim, and it fluctuates at an even interval. And using the telescope, we were able to focus on them and learn that not only measure the fluctuations, but we were also able to use the period and luminosity relationship discovered um, by Leavitt, and I was able to determine that the Andromeda Galaxy was about 900,000 light years away, much further than inside of our galaxy. Another colleague of mine who made a large investment to my cause and paved the path for me was Besto Sleefer. And Sleefer actually noticed that these other galaxies um, had red shifted spectral lines. Now that's confusing, but basically this is referring to the Doppler effect, saying that when something is traveling away from you and emitting waves, you see those waves as longer wavelengths. That's what we call redshifted, because redshifted um, visible light is the longest wavelength. So essentially, uh, by analyzing the wavelengths of different galaxies, we were able to see that they're moving away from us. Um, and I actually helped continue this work, or I continued this work with the help of Milton Humason. He was very integral in helping me in my work. Now, as far as my role in the project, we collected a lot of redshift data. Um, And after a while, we had so much of it that we were able to analyze it, categorize it, and not only was I able to determine and kind of categorize a few different types of galaxies that we had been learning about, but well, the redshift data, it was kind of hard to interpret because depending on how large the galaxy looked from Earth, the redshift data it increased and decreased a lot just based on the size of the galaxy, which was confusing at first. But I realized that we could actually assume all the galaxies were similar sizes, and then I equalized the data according to that. And after that, we just looked at the relationship between the velocity that each galaxy was moving and their distance away from Earth, as we can measure from their relative size. And we noticed a strong correlation that eventually became known as Hubble's law. Now, this was a really groundbreaking discovery for the scientific and especially physics community at that point. Not only did it have large implications in astrophysics, but as well as general relativity. So, like I had said earlier, until my research, most physicists thought that all the universe was contained inside of our galaxy, that everything we saw in the night sky was a part of the Milky Way. Um, but now we know that there are other galaxies out there. Now we live in an expanding universe. This was also a thought that most scientists didn't agree with. Most people thought that the universe was static, it wasn't expanding or contracting, and that it was maybe infinite or finite. Actually, Einstein, he believed that the universe was infinite and static, just like a lot of people did. And so when he worked out his theory of general relativity, it didn't make sense because that pointed to a universe that was either expanding or contracting. So in all of his equations, he added a cosmological constant. That was kind of a fudge factor for his work that made the math work out right. But when he heard of my work, he actually changed his mind and was relieved to be able to drop the cosmological constant from his equations. And it changed general relativity. He actually said this was the biggest mistake of his career, and he was so thankful for my work that he came to see me in person and thank me for it. Um, and I feel like that's a really important thing that a lot of people don't think about. But no, I was attracted to the sciences from a very young age. Um, I was always a big reader, and I loved reading science fiction novels. Even as a child, one of my favorite books, 20,000 Leagues Under the Sea. I just loved exploring. I loved asking questions, asking why, and trying to get to the bottom of why things happen, trying to decompress, or compress the universe into more smaller bites, into chewable pieces that we were then able to take and make predictions about the universe and test those hypotheses. So yeah, no, I was always a very logical person. Um, I went to the University of Chicago, and I studied the sciences there in undergrad. But I eventually, um, because of a promise that I had made my father, um, I studied law for a while, um, but nothing could draw me away from the sciences, and I always knew that that's where my heart belonged.